Alright, so today we're going to be going over some basic rules of exponentials and scientific notation. Alright, before we get going into a few examples, we just want to lay out some of the basics just to refresh everyone's memory. If you're pretty confident in what you're doing here, you can probably just skip over this video. But again, it's just a good refresher just to make sure everyone's on the same page before we get going into all of the notation that we're going to be using really through a lot of the class here. Alright, so first of all, if we're dealing with exponentials, we're going to want to write this as basically 10 to the x. Alright, and if we have just some general multiplication of these things, so if I have here 10 to the x and I'm multiplying this by 10 to the y, this is going to be 10 to the x plus y. Alright, so whenever you're multiplying two exponentials, that means that you're going to be adding the exponents like this. Another common thing that we'll also do is raise these things to a power. So 10 to the x, then you raise this to the yth power. And in that case, if you have two things raised to another power, you're going to wind up multiplying these exponents. And you're going to have here 10 to the x times y. Another common thing we'll often see is 1 over 10 to the x. And whenever you're taking the inverse of this, this is just equivalent to 10 to the minus x. Again, if we just combined, basically since multiplication and division are just reciprocal operations here, we can very easily just say if I have 10 to the y divided by 10 to the x, then this is going to be equal to 10 to the y minus x, right? Because this is just equivalent to 10 to the y times 10 to the minus x. So this is just going to be 10 to the y minus x. Right. So just using a few examples here because x and y might be a little arbitrary, but let's just use 5s and 3s just to demonstrate some of these points. So if I have here 10 to the 5th, multiplying this by 10 to the 3rd, that's going to be 10 to the 5 plus 3, which of course is 10 to the 8th. Down here, if I raise these things to the power, so let's say using my 5 and 3 again, so 10 to the 5th, and now I'm going to cube this, so that's just going to be 10 to the 5 times 3, which of course is just 10 to the 15th. Over here, if I have 1 over 10 to the 5th, that's just going to equal 10 to the minus 5. And then, just keeping with our theme, if I have here 10 to the 3rd over 10 to the 5th, this is going to be equal to 10 to the 3 minus 5, or 10 to the minus 2. Alright, now you might be wondering and saying, well, I have a calculator. Why do I have to worry about, doing this? I can just punch it into the calculator and it will do it automatically. Well, as we're going to be seeing in a few examples, it's very useful to just go through the calculation before you put it in the calculator, just to make sure that you actually do enter it into the calculator correctly. And trust me, you will enter it in wrong and it will give you a weird result, and it's really up to you to notice that this answer does not make any sense. Alright, one other thing about these exponential notation, what this means, if I have 10 to the 8th, that's really 1 with 8 zeros after it. So 1 with 1, 2, 3, 4, 5, 6, 7, 8. Alright. Or we have here 10 to the 15th, that's just going to be 1 with 15 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, ran out of room there. But basically, that's why we use the exponential notation, because it is a lot simpler than trying to write out all these zeros. And especially when you start using your calculator here, the calculator itself, has the problem that, you can't simply add all these zeros. So you're going to be having to use this exponential notation here. One thing to be careful of when you are dealing with these negative notations, it's not actually 5 zeros, it's one less than the 5 zeros. So this is actually going to be 0.1, 2, 3, 4, and then the 1. All right. A lot of times what happens is you might add an extra 0 in there and that throws your number off. And that's why it's really important, just use the exponential notation. Don't try to be smarty and say, okay, well this is the number I get and then I'm going to go here and then put the zeros in, because you might accidentally add 1 0 or not enough zeros. And even if you do know what you're doing, you might just hit the button one more time and then your number is going to be off by a factor of 10 or 100. So just use the exponential notation. It's a lot easier. And then down here, 10 to the minus 2, that's just going to be 0.01, just like that. All right. Oh, and then just as another little example, let's just say I were to go here, 10 to the 3 divided by 10 to the minus 5. Well, in this case, it's going to be the same thing. We're going to have here 10 to the 3 minus now a negative 5, which is going to be, 3 minus a negative 5 is 3 plus 5. So that's just going to be 10 to the 8th again, okay, which is the same as what we just had up there. All right. So that's the basics math that we're going to be dealing with the exponential notation, and just make sure you know how to do this, because we will be seeing this quite often. All right. Now, a new thing that we will can look at is, let's say we have here 530 nanometers. And what we will be seeing is that, if we're dealing with 530 nanometers, nano means 10 to the minus 9th. So this is going to be 530 times 10 to the minus 9th meters. All right, so this is actually a pretty common wavelength for visible light, and we'll be seeing that once we look at light and all its properties. Now, what you could do if you're just doing this on a test and you have this number, just write it as 530 times 10 to the minus 9th and be done with it. All right. Now, a lot of times what you may have to do, and maybe even in your math class they may have told you to do this, you always have to just reduce this to having the decimal point right over here. And if we do this, we could rewrite this as 5.30 times 10 to the 2. That's just a 530, just rewritten in scientific notation. And then times 10 to the minus 9th meters, which is just going to be 5.30 times 10 to the minus 7th meters. All right. So that's what we could do, and that's, it's fine. It's the exact same number as we have here. But I'm just saying, this is usually a lot easier and a little less prone to errors. And this is why. Let's take, on the other hand, if I'm dealing with 530 gigahertz. Okay, so that's going to be, somewhere, another high frequency radiation, probably in the infrared region there. And if we're doing 530 gigahertz, well, this is 530 times 10 to the plus 9 hertz. Okay, so notice the very similarity here. This is negative 9, this is plus 9. They look very similar, and you may think, okay, well, I'm just going to treat this exactly the same, but have to be careful here, because this is going to be 5.30 times 10 to the 2 times 10 to the plus 9 hertz, which is going to be 5.30 times 10 to the 11th hertz. So notice over here, while we were doing with the negative exponent, this worked out to be -7, and we're dealing with the positive exponent, this actually went to +11. And that's why I really suggest, if you have like these numbers, once we start doing these conversions, just leave it like this rather than trying to be smart and converting it over here into this notation, because what's going to happen is you're going to forget about the little negative sign, and instead of going up you're going to go down, and you're going to be wrong for one of these, and it's going to mess up your answer. So just be careful when you're dealing with these. They look very similar, but as you can see, they give vastly different results if you're not careful with this. All right. One other little thing is just a note on actually using the calculators here. So we have basically two calculators, and really they're going to have three very common little buttons on here, and this is how we can use the scientific notation. If our answer happens to be given with like a 0.00001 or something, and we want to get that into scientific notation. So first of all, if you look on the calculator very closely here, I'll just zoom in a little bit. You'll notice right here, I think as you can see that, I hope, it says right there, floating, scientific, and engineering. Okay, so FLO, scientific engineering, and this calculator, they'll be on sometimes different buttons. You just have to look for it, but right here we have floating, scientific, engineering. Okay, so those three little different buttons that we have to be aware of on each calculator. Okay, so the floating, FLO, this means you're floating. And this is going to be the default mode. So when you turn your calculator on, most of the times this is what you're going to have. And when you're going to be looking at it, this is just going to be the, you're just going to have here 1.35 or, 135 or 0.0000135, something along those lines. This is the normal mode that you're just going to see in the calculator there. All right, the next mode, which is the scientific, SCI, so this is going to be your scientific. And those can just be easily reached on your calculator just by going third, scientific, and automatically it just pops up. Or, even on this one here, you just go third, scientific, and it just pops up. And then you'll notice right here we have the little exponential zeros right there, which will just represent, of course, those exponents that we have, in this, up here. All right, and then when you have that, you're just going to have there, some number, the decimal point, some other numbers depending on how many you actually have, and then you're going to have there, the times 10 to the, x, whatever. And that's just going to be, whatever number you actually have there. The next one that you might use is here the ENG, which is the engineering. All right, and for the engineering one, this one's it's related to the scientific notation, but instead of it going number, decimal point, and then a whole bunch of numbers after that, it can go anywhere from here 1 decimal point with a bunch of numbers after it, all the way down to 999 decimal point with a bunch of numbers after it. All right, and when it's doing this, it's actually not going to be 10 to the x, but it's going to be times 10 to the, and here plus or minus because you can be positive or negative, 3, 6, 9, 12, 15, and so on. And what it's doing here is it's using the exponential notation like for the units. So we're going to be seeing, well, a little bit later, is that 3 is going to be either your kilo or your milli, 6 is going to be your mega or your micro, 9 is giga or nano, and so on. So this is just doing the notation. So we're going to be using like the scientific notation and the SI prefixes a little bit later on. So this can sometimes be useful if you just want to know what the number is and which number to use for the SI prefix for that. Okay, so as for a little example here, we're going to look at an equation. So here we have the energy is equal to Planck's constant times the speed of light over the wavelength of the light. Now, we're not going to get into where this equation actually comes from right now, but right here, Planck's constant speed of light, the wavelength of the light, these are values we can look up depending on which light we're actually looking at, and this is just a demonstration to show us what units and how we can actually use these things. Okay, so anyway, Planck's constant is equal to 6.626 times 10 to the minus 34 joule seconds. Okay, joule is a unit of energy, seconds, of course, is a unit of time. The speed of light, that's going to be 3.00 times 10 to the 8th meters per second. And over here, the wavelength is dependent upon which wavelength of light we're actually looking at. And we'll just use up here this 530 nanometers. Okay, so we'll have to put this in meters, so we'll just do here 530 times 10 to the minus 9th meters. That's 530 times 10 to the minus 9th meters. Now, before we go through any of this calculation, we can actually figure out approximately what order of magnitude these values are actually going to be. So right here, notice we have here 10 to the minus 34, 10 to the minus 8th, and 10 to the minus 9. So that means, just without doing any calculations before punching into the calculator, we have here 10 to the minus 34 plus 8, and then minus a negative 9, so that's going to be plus 9. So of course 8 plus 9 is 17, minus the 34, so that's going to be somewhere on the order of magnitude of 10 to the minus 17. And this is just a good double check, because if you happen to put this wrong into the calculator, like you happen to multiply this down here, you're going to get a very weird number. That's not going to be around 10 to the minus 17. So this is approximately what we think our value should be. Now let's actually figure out, well, what is the actual answer here? So we'll just go through here and let's see, our 6.626 times 10 to the minus 34. And by the way, when you are entering the times 10 to the minus 34, we just use this EE button, and it will do a little exponent. You can enter the stuff in quite easily. All right, times 3 times 10 to the 8th, and then we're going to divide that by our 530 times 10 to the minus 9. And this was going to work out to be 3.75 times 10 to the minus 19. As for our units, which are always very important, notice right here I have seconds. This is per second, so that's divided by seconds, so the seconds actually cancel out. And I have meters divided by meters. These both cancel out, and I'm just left with joules. So this is going to be my units here, is going to just be in joules. Now, we said that this should be about 10 to the minus 17, and here's 10 to the minus 19. Did we make a boo-boo? Well, no. First of all, we did have this 530 here, which is basically that factor of 100, so that's why 17, and now we're at 19. But additionally, if you just look at this, and if we happen to be off, we would be off by a factor of like 10 to the 18th or so if we happen to multiply this by 10 to the 9 instead. So we're if we're just within about 100 or 1,000, generally we're going to be okay. But if we start getting numbers that are millions and billions and more off, then you can say, whoops, I probably just multiplied instead of dividing or whatever when you're dealing with these numbers here. So just always be very careful of that. Alright, so once again, this seems to be a long video, so I will stop it there.